My dear students, today in this class we will discuss a relationship between k, eta and y. That is a relationship between bulk modulus, rigidity modulus and Young's modulus. In the earlier classes we already discussed two more relationships. Let us consider those two relationships here. Consider the relationship between y, eta and sigma. So that is the relationship between Young's modulus, rigidity modulus and Poisson's ratio. And this is given by y is equal to 2 eta 1 plus sigma. Let us say this equation as 1. Now consider one more relationship, that is a relationship between k, y and sigma. That is a relationship between bulk modulus, Young's modulus and Poisson's ratio, and this is given by k is equal to y divided by 3 into 1 minus 2 sigma. Let us say this equation as number 2. Now we will rearrange equation 1 and 2. Let us rearrange equation 1 and 2. On rearranging, one and 2, so I will rearrange this equation. Equation 1 and 2 I will rearrange. Y divided by eta, I am cross multiplying eta to LHS, and in the RHS 2 remains as it is with 1 plus sigma. And here I am distributing this 2 to each term here. This is 2 plus 2 sigma. Let us say this equation as number 3. Now I'll rearrange this equation 3 here. This is y divided by 3k. So y I am keeping at one side and bring this k to here in the place of 1 minus 2 sigma. So I just cross multiply with 1 minus 2 sigma this k. So now this becomes y divided by 3k, and here we left with 1 minus 2 sigma. Let us say this is as equation number 4. Now adding equation 3 and 4, now we will add equation 3 and 4. So on adding equation 3 and 4, so I'll add first this LHS term. This is y divided by eta plus y divided by 3k. Now I'll add RHS 2 plus 2 sigma plus 1 minus 2 sigma. Similar terms here, 2 sigma, that becomes equal to 0, which is having a opposite sign. Then we left with in the RHS only 3. Now y divided by eta, y divided by 3k is equal to 3. Y divided by eta plus y divided by 3k is equal to 3. Now I'll write once again that term here. Y divided by eta plus y divided by 3k is equal to 3. Now we have to add these two factors. For that, LCM is 3 eta k, and multiply this LCM with each term here, each factor here. This is first factor the first term becomes here in the numerator 3k y, this is y actually, then next second term becomes y eta, this is equal to 3. Here in the numerator y is common, so let us take this out. Y that I am taking it out, we left with 3k plus eta divided by 3 eta k is equal to 3. So now I'll keep y at LHS and bring remaining terms numerator denominator to RHS. So cross multiply here, this becomes 9 eta k. After this cross multiplication here, 9 eta k divided by this numerator I am cross multiplying, this is 3k plus eta. So this is the relationship between Young's modulus, rigidity modulus and bulk modulus. So here we have a relationship between k eta y. So we got a relationship between k eta y. So this is the relationship between k eta y. Now let us continue with one more relationship, that is relationship between k bulk modulus, rigidity modulus eta and Poisson's ratio. So again consider those earlier two established relationships. So again I will consider those relationships, two relationships. Consider the relationship between y eta and sigma. This is given by y is equal to 2 eta 1 plus sigma. Again say this is equation 1. Consider that one more relation, k, y and sigma, which is written as k is equal to y divided by 3 into 1 minus 2 sigma. Say this is equation 2. Now here we are establishing a relationship between k, eta and sigma. Okay, but here in equation 1 and 2, from these two actually we are arriving at the relationship between these three terms. And here you can observe in equation 1 and 2, so there is a presence of y, Young's modulus y, but here in this relationship we don't have that y, Young's modulus, so we need to eliminate that term here. So for that we will rearrange this equation 2 here. So I'll rearrange on rearranging equation 2 here, we get, so I'll keep that y one side and bring remaining terms to another side. That is a cross multiplication of this term. So this is 3k 1 minus 2 sigma. So let us say this equation as 3. So now from equation 1 and 3, so from equation 1 and 3 we will equate these two, equation 1 and 3. Here you can see in the LHS there is a presence of y, Young's modulus, so here they are same, so RHS must be equal. Thus 2 eta 1 plus sigma is equal to 3k 1 minus 2 sigma. Now let us simplify this. This is 2 eta. So distribute this, multiply this term to each factor here. This is a 2 eta plus second term 2 eta sigma. So this one becomes RHS 3k minus here 3 2 is 6 k sigma. Now again rearrange this equation here. I'll rearrange this equation. I'll keep 2 eta sigma one side and bring this term 6k sigma to LHS. So this is a negative sign here. When you bring this to LHS, that becomes plus 6k sigma, and the 3k as it is, and this term that is there, you have to send it to RHS. That becomes positive plus 2 eta, that becomes a minus 2 eta. So now here in this 2 term of the LHS, so in these 2 terms of the LHS, so what I did here in this term is, so I kept 2 eta sigma one side and brought this 6k sigma to LHS here. So I brought here to LHS. Okay. Then I brought this 2 eta to RHS. So this is a plus, it becomes minus. So now here sigma is common, that you take it out. This is, we left with 2 eta plus 6k, and this is equal to 3k minus 2 eta. Now sigma I'll keep as it is, then bring remaining term to RHS 3k minus 2 eta divided by 2 eta plus 6k. So this is the relationship that we got here. So this is the relationship between k eta sigma, that is so here we have a k, bulk modulus, rigidity modulus, and Poisson's ratio. So Poisson's ratio, that is a bulk modulus and rigidity modulus, sigma k eta, sigma k eta. So these are the two relationships.